Okay, here's the back page of the same lesson, the same 2.4. Again, I just didn't know how, if I would like time out the YouTube stuff. So I can look at all this, but notice they want me to determine the type of relationship. So if you remember on our last test, we had one that said, was it linear, quadratic, and so on? So we now need to determine that, because what if this is linear? So when I look at this, from 400 to here, that's going down 16. Now, if it was linear, it would be going down the same amount. But now, if I do this one, that's going down, that one's harder for me to do quickly in my head. Looks like it's going down 48. Then if I do this one, it's going down 80. So zero, see, I can tell this is not linear because it's not going down by the same amount. So then 256 minus 144, it's going down by 112. So it's definitely not linear. And if it was exponential from algebra A, when you divide these, they would have to be the same common ratio. So do you see how the numbers are not the same? So this is not linear. It's not linear, and it's not exponential. So this whole chapter is about quadratic. So you can probably guess it's probably quadratic. But let's do the next row, okay? So from 16 to 48. So if I take 48 minus 16, do you see how it's going down by 32? Then if you go from here to here, again, 80 minus 48, notice I'm just doing the difference. This is 32. It's going down 32. And then this one I can tell from here to here, that's down 32. So do you see how this is kind of like the second row? Well, every quadratic is squared. So it's kind of like second row x squared, which means this thing is quadratic. Now, they want you to use the regression model. If you knew your vertex, so if you knew which one of these was the vertex, you could use vertex method. If you had two intercepts, so see how I have one intercept? Actually, that's the y-intercept though. So if I had the x-intercept, so if I had this to be 0, I could use intercept method. But because I really don't have any of those, I don't have the vertex and I don't have the p and the q, then I'm just going to use my regression. So regression is essentially the fancy word for statistical. So I'm going to go to stat, and I just can't show you guys Desmos because of the way I'm recording this video. So I'm just using my calculator, but you totally can use Desmos if you would like. And on Friday, I can show you that if need be. Okay, so if you notice, I'm just typing in my numbers just like we did before. I'm just going to quick double check to make sure that I didn't mistype anything, and it looks good. Okay, so then I'm going to go stat, and I'm going to go calculate, and instead of picking Lin regression, I'm just going to pick quadratic. Now, for whatever reason, so I'm going down to the word calculate, for whatever reason, they give it to you in standard. They do not give it to you in vertex. So the nice thing is it doesn't tell me which form, so I can just do negative 16x squared. Now notice my b is 0, so I don't really need that. That's kind of pointless, like I don't really need that part. And then my constant is just 400, okay? So now there's my equation. Now it says what is the height after this time? So this is my t. So I'm just gonna plug that in here. And then I get 353.76, and this is in feet, okay? And then now it says when, so they're looking for the height, is this the h. So this is like your y. So your y is 300. Now, if you wanted to, you could do this in Desmos, which again, I'm not going to be able to show it very well here because this is a graphing calculator. But if I go here and set this to 300, we could just essentially see this is going to start at 400 and it's going to go like that. So then 300 would be lower. So 300 would be here. So we just need to see where does it cross right there. Okay. So again, that would be easy to do in Desmos, but since I don't have Desmos available right now, I'm just going to go like this and I'm just going to solve this algebraically. So if I subtract 400, if I divide, so negative 100 divided by negative 16. And then I'm just going to take the square root. Now, typically when you take the square root, you get positive or negative, but because we're dealing with time, then we would just have the positive. So we would just leave this as our positive. Now, if you're using Desmos, you probably see that exact same thing right there. Again, it's just I didn't know how to switch between this and Desmos to show you that, but you could easily do this in Desmos, okay? So if you want to look at the next one, again, the first thing you have to identify is what type of relationship. In all honesty, you don't even care about the story problem. So when I look at this, I'm like, ooh, you're up 5. Oh, you're up 5. You're up 5. So do you see how this is like the first row? That's like just plain old x. X to the first power is linear. So in this lesson, they switch between quadratic and linear because you already did this last chapter. This is like chapter 1. So again, if you want to, you can use Desmos. In all honesty, I could probably just do this by hand. Does everybody see that my slope is 5? So if I do the pattern the other way, does everybody see that this would just be a 0? So then my data would just be essentially 5x like plus 0. Or if you don't want to do that, you are more than welcome to do this in your calculator, but just for time's sake. So then if you're born 1 hour, so now you're just going to plug 1 hour in here, but be careful, this is minutes. So x would have to be 60. So if I do 60 times 5, that should be what? 300 babies are born. Estimate how many minutes after midnight it takes for 100 babies. So again, if you wanted to, we could go here and we could type in 5x and then we could type in 100. Now think about the graph again. It's starting at 0 and then it's going up 5 over 1, up 5 over 1. So remember, it's linear. So then you just have to see where the 100 would come in and where do they cross. But again, if I hit graph, you can't see the 100 unless I change the window. So it's probably easier for me just to go 100 equals 5x and then just divide by 5. And then I get 20 minutes. And then I'm done. So sometimes I think Desmos is awesome. Like maybe for this one, that's great. But I don't really think Desmos, like it would take you longer to like get to Desmos and type all this in than you could just do it by hand. Okay. So hopefully 2.4 wasn't too hard. But again, the whole second half of the chapter is all about how do you write equations with different parabola information. So like, what are they giving you? Okay.